out of your pocket. This is going to be an interactive talk, and I would really appreciate it. We have a lot more fun if you play along. Thank you very much for the introduction. My name is Liam Randall. I've worked on a number of very large open source communities. I was one of the original people building ProZeek out of Berkeley, Tap the World, large-scale protocol analyzers. I actually created the very first Kubernetes company in 2014, which I sold to Capital One. I was the first investor in OSquery. I worked on Cloud Custodian. I put that in the CNCF. TLDR, I do a ton of stuff at the intersection of open source and enterprise. And I've never been more excited about anything in my life than WebAssembly. Connect with me right on LinkedIn. I'm easy to find. I want to start, I don't know if this will play or not, with a quote.
We were fighting each other too early in the process. There's this mindset that the winner would take all. The truth is the winner takes all the burden.
I played this last week at Wasm the Linux Foundation event that's centered around WebAssembly. And as one of the people that served in the container wars back in the day, there was always this us versus them before people finally got the mindset that cloud native was really better together. And today I'm going to talk about some hard truths around Kubernetes and around application development, but nothing that we're going to talk about today is about replacing or defeating containers. The reality is, though, is that containers don't fix applications. There's three major problems that we find with containers today. The first is that we embed libraries at compile time versus attaching them at runtime. The second is that these libraries are tightly coupled with specific CPU services as well as the CPUs themselves. We build a container for x86 or ARM. We include drivers for MySQL versus Postgres. And the third is that the cold start time means that containers have to be provisioned and running in advance. Network connections are measured in milliseconds. 200 milliseconds is considered interactive. Containers take half a second or much longer to start, even highly optimized ones like Lambda. So when people ask themselves what comes after Kubernetes, the leading candidate right now by far is WebAssembly. It follows this progression of technology that we've seen over the last 20 years, where organizations come together and rally around the common complexity that plagues us on a day-to-day basis. Go back to those of us that were building tech in the 90s. When we wanted a new app, we called our Dell rep and we got a new server. They said, this is crazy. I can gain so much if I can just virtualize and combine these PCs. And then we said, well, I need more room for VMware servers. And they said, well, this is crazy. Let's all go in on public clouds. And then we got to public clouds and we said, why am I configuring an operating system to deploy my application? That's insane. Let's go to containers. And then why am I writing a different deployment spec for Azure versus Oracle Cloud or AWS? Let's bring in Kubernetes. It's that community and that common complexity. And the next obvious common complexity are the libraries that we use to build our applications. Who's heard of WebAssembly before, any curiosity? A surprisingly large number of people. WebAssembly's been around for almost a decade. It started as what some people refer to as the greatest hack of all time. What would happen if we would take C code and transpile it to JavaScript? Well, Doom runs in the browser. It sure enough runs anywhere, and WebAssembly has really climbed beyond that. Think of it as the world's smallest virtual machine. You're already using it today, as I'll show you later. The world is already dependent and adopted on WebAssembly. It's one of the reasons why I'm so bullish on it. But it's really tiny and it runs everywhere, even inside your browsers, for example. It has an incredibly fast cold start time, measured in microseconds, which means you can start per invocation, as opposed to keeping a lot of things running in advance. And everything running in WebAssembly runs in a capability-driven, deny-by-default sandbox. That's a mouthful, but we'll unwind that in a minute. Now, as I mentioned, I'm incredibly passionate about open source. And one of the additional projects, if you've heard of Cloud Custodian before, that we also launched out of Capital One, was this. It's now in the CNCF. It's actually about ready to go incubating. So it'll be one of the 15 or 20 larger projects in the Cloud Native Computing Foundation. It's called Wasm Cloud. And it's the platform that we're going to use today for demonstrating all of our talks. There's stickers in the back. It's an awesome community. We have Wasm Cloud Wednesdays where we geek out about WebAssembly. We've been doing that for like 3 years. We haven't missed a week. It's completely open source. It's built in Rust. It's compatible with Kubernetes, but it's not dependent on it. It's running in all kinds of places, as you'll see throughout this talk today. And what it really enables you to do is to orchestrate WebAssembly. So, you got your phones out? Let's deploy a component. If you click this QR code, what should happen is essentially what happens on the right. You're going to log into a little online platform that I've set up, and you just open up a little browser and click Save and Deploy. You're going to deploy your first set of WebAssembly components, and then we're going to take them apart, we're going to delete them and throw them all around the room to different places. I'm going to actually pull this up live so people can go and finish clicking through the deployment. But essentially what should happen is that you should deploy something that looks like this. So you should have a set of applications here that will generate an XKCD comic. Now, typically when you build an app, you would put all this stuff in a container, you know, a web client, a web server, and a bunch of other things. And when there's a bug, you would have to update the whole thing and push things out to CI/CD. Now, WebAssembly starts by using a standard called components to break these things up into little tiny sandboxes that can be shared. They're also denied by default and capability driven. So this particular sandbox only has the ability to speak HTTP out. And this particular sandbox only has the ability to take HTTP in. And this is my sort of business logic here, where I'm taking, let's see here, taking my app, on the right demo? No, it wasn't on the right demo, let's go to this one. And I'm pulling in a new comic here, which is gonna randomize the comic for you. Now, what would happen if we deleted that? You know, if we came in here and we went to our app and we just said, good night, goodbye, thanks, sweet prince, and our app is dead. There we go. All right, our app is dead. Now, these WebAssembly components are incredibly tiny, and we can actually deploy them to all kinds of places, even across different operating systems and CPUs, all without changing them. So let's go ahead and deploy this to another cloud, and I'll show you my kind of environment here in a second. Actually, let's deploy this to Falling Darkness. And if we come back to this host and reset, our application is now self-formed and self-healed. Now, I've just deployed one more copy of it, which isn't all that exciting, but we could be very deliberate about where and how we deploy these little sandboxes. We could put them on multiple clouds, for example, or we could put them on multiple VPCs. Here I'll pick, somebody want to say Azure or Oracle or something like that? What'd you say? VCP. I got Azure, Cosmonic, or Oracle installed here. So I'll go ahead and just pick Azure, and I'll go ahead and just deploy this to Azure. So this is now running across my MacBook, which is where that first host was, here on stage, as well as to Azure. And if we were to close or delete my MacBook, our application still works. These little tiny Lego blocks are not only self-forming, but they're self-healing. They sit on top of this mesh underneath that lets us create applications that are highly available and highly resilient. This tech was originally designed for running inside of a browser, but now it's running everywhere. It's running on Fastly, it's running on Cloudflare, it's even running on top of Kubernetes. Now, WebAssembly is kind of hard to understand and to wrap your brain around it, but just think of it as a little tiny CPU. It doesn't have an operating system, it doesn't really speak strings or structs. In fact, it's really just 3 integers in a trench code. You put numbers in, and numbers come out. Now, what's neat about WebAssembly is that pretty much everything can compile to it. All of your static languages, many of your interpreted languages, and we're even working on big languages like Java to squeeze them in there. And once you create what's called a WebAssembly module, or from a module you can create something called a component, you can now run and deploy this everywhere. It's very powerful. So this component standard essentially maps out to cloud-native infrastructure. There are components for things like SQL, components for things like key-value stores. They're generic, they're pluggable. So a key-value store could plug from Redis into AWS Elasticache or into a Nash Jetstream MapKB, whatever you'd like. So you have this ability to hot swap between not only CPUs, but also the services that are running on top of them. Let's actually take a look at one of these components here. This is up on GitHub already. Here, let's another begin. But what I want to do is I want to actually open up a WebAssembly module and actually show it to you. Because they're not really all that scary at the end of the day. Actually, it's right here. Sorry about that. There we go. I'll hit dot and I'll enter editor mode here. Now, WebAssembly starts by taking, in this case, the C code. I don't know if there's any power systems engineers here, but this is the C code that you would use for implementing a voltage regulator. Sort of keep my voltage at 120 somewhere on the current or back plane. And there's the WebAssembly standard supports two modules. There's a .wasm, which is just all these integers all the way down. It looks like CPU code. Or there's human readable code called a .wat. And if we look at this .wat file, what differentiates a component is very down at the bottom, we have the sort of imports and exports. And think of this as the top of the Lego block and the bottom of the Lego block. This is where we describe the structs, the variables, what comes into the module and what comes out of the module. At a really high level, if you're not a developer, you don't really need to worry about this because the tools build these things for you. You start with your existing Python or C, and this is just the intermediate format that kind of comes out the back end. It's incredibly powerful, and it's being adopted very quickly, as we'll see. So there's the three integers in the trench code. It's kind of hard to see there. So we have this CPU, and I can put numbers in and numbers out. On top of the CPU, we're building things called application frameworks, and that's where CNCF Wasm Cloud comes in. As an application framework, it's very powerful. It focuses on orchestrating those Lego blocks so that you can run them everywhere. It comes with a whole set of Lego blocks included that lets you implement your browsers and logic, and we're already running it in today's demo across maybe a dozen different operating systems, 3 or 4 different CPUs that we're going to orchestrate around. And what makes CNCF Wasm Cloud different is it gives you this orchestration and this connectivity across a mesh lattice network. So when I was building my application earlier, the web server was actually running over here in AWS East. The XKCD app was running here on stage on my laptop, and the web client was actually running down in Texas on Microsoft Azure, all running in different operating systems. Let's do another example. Let's do a really tiny one. I don't know if anybody can see, but here on my badge, I actually have a little Raspberry Pi. This is a 64-bit ARM, and I pre-staged this demo, and demo gods be praised, that Wi-Fi be good, that this is going to work, because I'd actually like you to maybe connect to it. So the web server is running in US East over here on AWS. Down in Azure in Texas, I'm actually running the business logic here. And then on stage, I'm running a little provider that's attached to the LCD here. And this is crazy, but here's my QR code. Curl me maybe? Anybody? If somebody wants to hit that, see if it comes through. Let's see if I can just refresh it. This is the URL. All right, it's actually working. Did you get a response? Your phone? Did you? Oh, here. There you go. So this is coming right to my badge right now. And this whole network response time is happening from 0 invocation. So even on this tiny device, we can invocate every time you click that button. You should be able to send me a nice little message. Please don't send me anything too cruel to pop up on my badge. I'll leave this on later if you want to curl me later. But let's go ahead and move on. I think you get the demo. It's at liam.cosmonic.app if you'd like to send me a message later. Now, I understand what you're thinking. WebAssembly sounds great, but we got all this cloud native stuff. And WebAssembly is awesome, but think about all the projects we have to sort of tie everything together. Now, you're talking to the person that created the very first Kubernetes company and went on to lead Kubernetes at Capital One. So I've spent some time, I've deployed some stuff, and I've learned some lessons. And I have to say that platform engineering and service mesh and the idea that AI can write the code are challenging for 3 different reasons. For platform engineering, you're essentially saying you're going to build a big abstraction yourself, and it's going to be a perfect snowflake that you run in your own network. That's probably not going to work. Service mesh is actually a good idea. Take all the complexities out of each app, stop putting them in each and every app, and put them into a shared common rail. And AI can write the code, but it's just technical debt that you have to maintain. Because, as everyone who's built an application knows, that the cost of free is very high. The shocking truth about development is that 95% or more of every application that you build is just open source code. It's the common boilerplate you use to handle things like databases, message queues, right? UIs. And enterprise applications will start and try to make your life easier. They'll give you the golden framework. It's like that Michael Keaton movie where he makes copies of himself. And they make a copy of a copy of a copy of a copy. And you end up with a total disaster. This is where modern cloud native is today. We've made phenomenal leaps through Kubernetes and with containers, but we still have so much complexity left to go. I had ChatGPT create me a slide, I just didn't have a chance to put it in here, but it was to count the number of lines and contributors on each layer of the stack, to CPUs, to Linux, to Kubernetes, to containers, to your individual app. You're not going to get away from open source, right? It's not a question of, is it open source or your own private terrible version of everything? Open source produces a better version of everything, but what we need is just a healthier relationship with it. We need to stop copying it over and over and over again. And this is the brilliance of the WebAssembly component model. The component model delivers applications. We just published a case study with Adobe that are 200 times smaller than traditional Java-based applications. Now you can sandbag that a little bit. Let's be honest, you could start with Go and build a from-scratch container, but you're still pulling a ton of open source code even into that from-scratch container. The applications are remarkably less code, the security is completely portable, and what it translates to is developers have more time back in their lives. So many of our developers today have simply been turned into boilerplate farmers. My job is to take all the red and yellow boxes and turn them back into green. Between that and operations, developers are typically spending 75% of their time on operations and maintenance. It was a study published by Deloitte. But the trend that we actually see happening in the infrastructure today is this trend to remove complexity. It's this trend towards service mesh, right? Stop putting things into each app and make common rails. It's this trend towards frameworks like Dapper, or abstractions like Wasm Cloud, or I am a corporate shell, so maybe even Cosmonic. And this is the goal. I mean, this is what platform engineering is trying to do, this is what service mesh is trying to do, and this is what the WebAssembly component model already does for you today. It lets you reuse components, frameworks, languages that are implemented in any language. It gives developers the choice to write their business logic in any language. And it lets you combine these contracts in ways that are flexible, portable, and completely scalable. And now you may think, hey, who's this Liam guy that just coincidentally keeps picking all the awesome open source software that goes on to dominate the industry? But it's not just me that's saying that. If you follow Thomas Tung's, an epic venture capitalist, go subscribe to his news list right now. He had this awesome post at the beginning of this year called A Flare Across the Clouds. And he observed that the Home Depot model of computing, the growth rate is falling. The idea that to build an application, I'm going to start by going to the Home Depot cloud store, I'm going to get a VPC and some networking, I'm going to get all of these things I need to build and build and build to deploy my personal blog, is insane. And nobody's doing it anymore. If you're deploying blogs today, you're using Netlify. Here's my stuff, just run it. I don't care where you run it or how you run it. Just do all that stuff, right? That's platform engineering. And Fastly, Cloudflare, and Cosmonic are already doing this today. And coincidentally, we all use WebAssembly. Now, if you go to Fastly or Cloudflare, they don't necessarily come out and say, hey, look at this amazing technology. They give you an experience. They talk to you about outcomes. But underneath the hood, WebAssembly is what's taking over the network. And I think it's been observed many times before. In this case, to me, it feels somewhat obvious, but the future is already here. It's just not evenly distributed. And the sooner that you stop wasting time with all of the maintenance of applications that doesn't add business value, the faster you can get back to actually building your applications and solving your hard problems that matter. So who are the early adopters? Anybody ever used a little app called Amazon Prime Video? Anybody heard of that? Tiny little company, right? A to Z? You're using WebAssembly. They support 8,000 unique devices, CPU and operating system combinations. They surely don't write 8,000 unique versions of their software. Streaming's really been adopted quickly as a niche, but major players like Shopify's had WebAssembly in production for 5 years. They say they provide 80% of the shopping cart, and their providers provide the other 20%. Coupon codes. Anybody got a side hustle in here? Somebody Shopify expert? Coupon codes, integrations, CRMs. Well, typically you might say, hey, I'm going to throw you a post request and you throw me back business logic. But it was the slash that effect. Shopify would crush anybody in their platform. So they said, hey, give me your code, I'll be the platform, and I'll run your code for you. Bosch, Siemens, Mars, Goldman Sachs, lots of other companies have already started using WebAssembly, Autodesk, Photoshop on the web. But that works great for those companies, but this is DC. And in DC, if there's one thing we work on, it's hard problems that matter. Defense, financial services, energy systems, telco, 5G. Does it work for these environments, and how can it help? Regardless of what industry you're in and where you are in that transformation, the last decade was dominated by this great lift and shift into the clouds, but what everyone is struggling with today is building out towards the edges. Everybody, if you take the generic CIO, they're going to come in and they're going to say, all our apps are going to be mobile first, and they're going to be real time and streaming, no more batch processing, because we need to make everything personalized and proactive, and put some AI and ML in there while you got some time. But if you take those requirements and you actually play them forward a bit, what you end up with is distributed, distributed, distributed. For lots of reasons, not just latency and determinism, right? My Tesla has got to work regardless whether it's connected to the web or not just because the data's on the edge, but also sleeper use cases like privacy and security. This is regulatory town. Anybody see Facebook get whacked for $1.3 billion for shipping data out of France? The internet is already being balkanized. No one wants their data shipped out of country. They want to hold it in their country so their intelligence services can rifle through it instead of ours. Too close to home with that joke? Sorry. Didn't mean to offend anybody. We love you. I promise. Limited or deliberate autonomy. Those are the real sleeper reasons that are pulling our services to the edge. And the reality is when we talk about those three problems earlier, it's the regulated organizations that suffer the most. So let's do another example. Let's do a big example. Let's take a telco or the Navy or a big financial service. And let's talk about how WebAssembly can be used to start by just scaling to my laptop and then scale to megalith or monolith, right, in either direction. Run across just VPCs or run right across Kubernetes. So what I've done here is I've pulled together the generic telco. I just sketched out core nodes, edge nodes, radios, and towers. I've spun up a whole bunch of these WebAssembly hosts, a bunch in the cloud, and then we're going to run AI and ML across them as well. Sounds like fun. So let me show you the environment first. Actually, let me show you this environment first. All right, so here in the background, each one of these nodes that pops up on screen here is a separate WebAssembly Wasm Cloud process. And each one of those is then a part of this flat, self-forming, self-healing mesh, this topology. Maybe a little small to see, but I try to put some little pictures in here, like that's supposed to be a core, that's supposed to be a tower. I'm not really very artistic, maybe kind of cheeky. And I've gone ahead and deployed a couple of apps here to give us a starting point. So I've taken my apps, and I've got apps here that are sketched out as towers, as edges, as core components, and even as user devices here. And now we can take these apps and we can write a recipe for them, just like you would write a recipe on Kubernetes. We use the same specification. It's called OAM. I saw somebody in the back wearing a Helm t-shirt. Taylor Thomas, the author of Helm V3, is on my team. He wrote all this stuff. He's a pretty wicked smart dude. But let's look at Tower, for example. And we'll come in and we'll just sort of look at this YAML. Now, you actually don't even have to be too nerdy to understand it. You basically pick out your Lego blocks. I want this Lego block, and then you can say how many copies I want running, and then you can say what are the labels that I need to use in order to deploy them. And you can even create things like a daemon set. And this all works in the open source. Every demo that I've done today, my badge here on stage is running Wasm Cloud, this laptop's running Wasm Cloud, it's all running Wasm Cloud. And then I want to attach that to a web server that's going to be running in Cosmonic with some additional criteria on it. But what I can do is I can actually, and if I do that, which I did, to save us a little time, you can see I've got one copy of all of these things running. To save us a little more time, I went ahead and created a few deployment buttons here, just like the QR code that you started with. Let's take the tower, and let's go ahead and click on it. And what it's going to do is it's going to create a new recipe, and it's going to say, well, on everything that's called a tower, let's go ahead and just run one copy of this. And I'm going to do this live for you so you don't think I'm messing around. We're going to call that OAM, and let's just go ahead and save and deploy. All right. So this daemon set will then go to all of those towers that are out here, and it will reconfigure all of them to match the recipe. And it's even better than that. If there's a component that is missing, like earlier when we deleted that XKCD app, it'll automatically find the next closest Lego block that matches its contract. It's very cool in how it works. The message bus that we live on top of is also open source. It's called NATS. It's very powerful. And essentially it just lets you subscribe to topics, and it does a little routing of messages and services. And we can continue to stack this up higher and higher and higher. We could deploy different recipes depending on labels, like country code, or like regulatory domain, or certification. This data center is PCI DSS certified. That data center is not. This laptop is top secret. That laptop is just secret, right? Those labels are applicable and very powerful, and if you've been into the guts of Kubernetes, it's the same way Kubernetes works. It's a label-based system. I know we're running a little behind, so I'm going to go ahead and move on past this one a little bit. That demonstration may seem very lightweight, and you can do that today in Kubernetes. I don't know if you can walk up on stage, flip it to small badges, big things, multiple clouds, different services with Kubernetes, but you can certainly do this with Kubernetes as well. But what that demonstration, although it was fast, really just showed is the illities of software. Anybody hear this term before? The 5 illities of software, the 7 illities? The illities of software are the sort of principles that you aspire to when you're building your apps. When you're developing an MVP, it runs right here on my laptop. When I need it to be reliable, available, extendable, and portable, I start thinking about running it in different places simultaneously. And that's where things tend to get complicated quick. But in the way that Wasm Cloud and WebAssembly work together, these illities are now nods. I could go back into that deployment manifest and say run 10 copies of it everywhere. Or run it across 10 different servers, all without making any changes. Really, the power comes from the open source standards that are defined in WebAssembly. But I think the user experience that Wasm Cloud puts forward is very nice. Because what it enables is this capability-driven orchestration, where you can start to think very flexibly about what I want to do, my application architecture at one level, and that can be completely distinct from your application topology. My application architecture started just running here on my MacBook, 3, 4, 5, 50 different pieces, and my application topology, you can just turn the dial, and now it can be running in 500 places or 5,000 places, right? And I want to point out that this is not science fiction. If you've ever used Fastly, if you've ever used Cloudflare Workers, or any of those services, you're using WebAssembly already. It's exactly how they work. It's an amazing little standard that more people should be aware of quickly, given the desire to bring things out to the edge. So we'll do one more demo, and then we should be pretty close on time. Might have a few minutes left for questions here. This is one that BMW donated to the Wasm Cloud ecosystem. They apparently use Wasm Cloud at some point in the production of BMWs, and they've done a nice talk about it. And here's our application architecture at a really high level. Anybody play with ML stuff, any AI? All right, here's essentially what it works. We take pictures of kittens, few cats, and we send them to this thing called a preprocessor. And what the preprocessor does is it takes our pictures of cats and it turns them into a set of vectors. Now that does two things for us. Typically the vectors are a heck of a lot smaller than pictures of cats, and it also is a one-way hash, right? We can go from kittens to vectors. We can't go from a set of vectors back to a specific set of kittens. So these might be good candidates for running out on the edge, right? Compress the data, bring it in faster, protect privacy. Now, when we get into the center of the model, this model actually has multiple machine learning models for interpreting pictures. And depending on your requirements for privacy, for availability, or for performance, you can send it to the big model running up in the cloud. Or you can use the little one on the edge. That'll be the last time I did voices, maybe. And then a vector comes out, and then you interpret that, and then you send back the results. So let's actually, and this all runs in Wasm Cloud, of course. It's up on our GitHub. I can point you at it later. The fictional world that I'm trying to convey to you here is that across this disparate infrastructure, you could then deploy your machine learning model in a way to optimize it for various principles around privacy or something else. Now, in reality, the disconnected use case, DDIL, for you DoD folks, might be less secure by your definition. I'm not trying to harp on a particular definition, I'm just talking about the attributes. So let's go ahead and play with this one. So I've already deployed it. It's got a few different actors here that are kind of running all over the place. These are the image filtering pieces up here that take my images and turn them into vectors. They also will normalize the image and resize it. A machine learning model is trained on, a 224 by 224 pixel image at a certain bit depth with a certain color correction and a certain ratio. And I'll just go ahead and pull this up here, and just for urgency, I'm going to use MobileNet, which is the side model. We'll send it an espresso, which is 84% espresso with our little model, 20, 30 megs. And let's also send it maybe the piano, right? Piano, it's 50% a grand piano. Now, if we route this instead to ResNet, which is a common open source model, we just look at those same two pictures, we suddenly get some pretty dramatically different results. We're 99% sure that we're looking at espresso. And we are, I'm sure some similar confidence level because I chose those pictures in advance, 90% higher on the piano. Who could have predicted those results? That's not the point of using the AI models. The point is that WebAssembly brings some phenomenal properties to everything that you put into WebAssembly, including AI and ML. So this, as I mentioned earlier, technology is driven by themes. And the theme of the last decade was this great lift and shift in the clouds. Take all the crap we run in our own data centers, put it in the container, put that in ECS or Kubernetes or Fargate or whatever your option is. And the attributes that made that possible were a common format, community format, the container. And with WebAssembly, we have something different, and I'll echo Chad, who mentioned pets and cattle. I think with WebAssembly, we now have a third option, shrimp, right? Teeny tiny little functions that can run anywhere and are already running everywhere. They're running your living room, they're running your phone already. They're all around you. And this is the first time I've ever said pets, cattle, or shrimp in public, so thank you for the picture. I'll put that on Twitter, see if we can get it trending. And if the last decade was dominated by this great lift and shift into the cloud, our next decade is dominated by bringing our compute to the data. My name's Liam Randall. I'll hang out here. I'm super easy to find on all the things. Thank you for sharing some of your time with me today. We have 2 minutes for questions.
Okay, a couple questions. Let's see.
All of this marketecture, is what I call this, marketecture here, is up on cosmonic.com. If you want all the original versions, you can just go click and download it. If you'd like my whole presentation, so you can give it yourself, go in peace, I'll send it to you. Just send me a note.
I have a question for you, Randall. Somebody's asking. So, sounds like a serverless, but in a different way. And recently we heard the news that serverless is not that cool anymore since Amazon Prime
Great question.
got off it. So you're throwing us back into serverless. What do you think about that?
WebAssembly is going to dominate fast. Like it's done, right? The next Lambda, the next whatever Azure calls their Lambda, or whatever Oracle calls their Lambda, it's all going to be Wasm, right? It starts from 0, it scales to 0, cold start time. It's more secure. People like Fastly don't even put it in Firecracker because they give you a fixed set of capabilities. They go, hey, you only get HTTP and KB in this box and you're stuck, right? Maybe if you want to give people custom capabilities, you might put that in Firecracker like what Cosmonic does, but that's neither here nor there. I'm not going to log into my back end, but what Wasm Cloud is designed around is microservices. It's designed around event sourcing, and we actually released this whole event sourcing framework. We've done a couple talks on it this year, where you can build, large-scale material applications using things beyond FAS. FAS, I think, is going to go to 0, and it's all just go to WebAssembly very quickly. But WebAssembly can be used in other architecture patterns as well. I couldn't have prompted a better question. Thank you for that. I'll give you $20 later. Yes, please.
Describe the security paradigm for me that changes. That changes with Wasm. Right.
Describe the security paradigm.
Right. So like I'm just getting used to understanding like what security things I still really have to pay attention to in Kubernetes. What can I not outsource when we get to a Wasm paradigm?
WebAssembly already runs in a lockdown sandbox, and the sandbox has a separate memory space, and it has it has separate linear memory, and it actually brings all of this crazy properties to your application. There are people that are exploring, if I put something into WebAssembly, do I now have this this new boundary? And you can take multiple WebAssembly components. When you plug them in together, you still get separate sandboxes. It's a shared nothing approach. There is a separate standard that lets you point to some outside object, say like, hey, look at that big stream of data, like, don't copy that in, or pass that by reference. But it's a vastly superior and capability driven. Now, capabilities is a concept that you're already adopting, whether you realize it or not. Everybody's used a phone and a browser, but if you take a look at a particular page, you can find out, has this web page asked for any specific capabilities, like, can I use your microphone, or can I use your camera, right? And your phone and your new MacBook does that as well. Those are capabilities. So what WebAssembly's done is, they've taken all those common ideas like KB and SQL, and those are mapped as capabilities. So when I start, I'm putting my WebAssembly sandbox here, I get access to nothing. I can't open this file. And if I need access to that file, you have to specifically grant it. And really what we're trying to evade are whole classes of problems. I mean, log4j, bash bug, they're just failures in the Knuthean abstraction of services when I can go from a web request, evade it and drop out to bash. There are other people that want to take WebAssembly and implement POSIX, and that is not a great idea. I'm just going to tell you what I really think. Because we have a great abstraction for POSIX. It's called a container, right? WebAssembly decomposes the ABI into smaller ABIs, application boundary interfaces. What that means is that each boundary is no longer constrained by everything around it. Think if I want to iterate POSIX. The whole thing's got to get iterated. File opens, sockets, right? When we break these into tiny little pieces, everything can have its own velocity now. If I've got some app here that just opens files, I don't really care what happens in socket land, because I don't have the ability to use it, and none of that code's been pulled into my sandbox. The geniuses at Mozilla originally invented this, and they're the folks behind things like Rust. It's that same group of folks that are really all in on WebAssembly. And at some point, this stopped being an iterative world, and it started being a movement about WebAssembly. This isn't just the next big thing. I think this is the final abstraction in tech. Because the only thing that you need to bring is your business logic.
Thank you. All right.
I'll get off my horse.